Welcome to Wastewater Monitoring Analytics Module 0, Wastewater Treatment Plant Data Preparation. This is the first in the Wastewater Analytics Level 1 training videos. I'm Rebecca Schneider, an analyst in the Data Science Division at the Houston Health Department, and I'm presenting on behalf of the Houston Wastewater Epidemiology's Analysis Team. We wanted to call this module Module 0 in order to highlight the steps before the analysis begins. In this module, we will cover missing values, lab alignments, and flow-based normalization. Below is an example of the data we receive each week. We receive the same information in the same format each week, and this file includes facility and its population size, the lab the measurements come from, as we measure at 2, measurements and copies per liter of wastewater, detection limit, and flow in million gallons per day, and flow in liters per day. Since our data is used in many different analyses, it is important to impute values when non-detects are observed. As the caution sign says, these non-detects should not be removed or set to 0. This decision can severely bias the analysis. Our rule for imputation is as follows. For observations below the LOD but above half the LOD, retain that value. For observations from 0 to below half the LOD, replace with a random number from a uniform distribution 0 to half the LOD. There are other standard rules for handling non-detects listed here. Replacing all non-detect values as half the LOD artificially reduces the variation. Replacing all non-detect values as the LOD has the same issue on top of artificially inflating measurements. And lastly is the, quote, gold standard of Kaplan-Meier. We put together a white paper that compares the sensitivity of our trend analysis based on our simple rule in the last slide and the Kaplan-Meier method. The results indicated that our simple rule was on par with the gold standard Kaplan-Meier estimator. Next, on missing values, there are many reasons a missing value can occur. It can be missing copies per liter wastewater measurements due to weather. As we had the freeze in Houston in February 2021, no sampling happened that week, so our analysis had no copies per liter for that week. Or it could be a missing flow value. For copies per liter, missing values for 1 to 3 weeks can be imputed with linear imputation or cubic imputations. And missing flow values are replaced with the median flow for that facility. In the note below, we want to stress that we identify imputed values in our analysis as we do not want missing values to drive our trend and therefore our messaging. This is an example of the note I just mentioned. In our graphs we review each week, we include a circle on all imputed values, with the colors meaning different things. For example, this one indicates the measurement was below half the LOD. Next is lab alignment. In Houston, each sample is analyzed at 2 labs. We are fortunate to start and continue the wastewater program with our colleague Dr. Lauren Stadler, an international leader in wastewater epidemiology. And starting in 2021, we were fortunate enough to bring on our own health department lab and have their expertise added to this program. These 2 labs have agreed and effectively signed off on each other's methods, but there will be slight differences and equipment will not be exactly the same, so alignment between lab measurements is required. When comparing labs, we need to recognize what target is measured at each lab. This is Houston-specific, but we started with Rice and Baylor labs in 2020, which both measured the N1 and N2 targets separately. The Houston Health Department lab joined and is measuring the totals of N1 and N2. We use the average of N1 and N2 for both labs. As we already had Rice levels measured, we didn't want to switch to reporting effectively twice as much virus counted with the Houston Health Department method. With that covered, we then developed a regression model. As Rice was our initial lab, we used Rice as the dependent variable and the Houston Health Department lab as the predictor. So we are effectively bringing Houston Health Department to Rice levels. In the bottom right plot, the black points are the original measurements, with orange the results of the cubic regression and blue the linear regression. Black points, as you can see, are not perfectly aligned. And so you could say we are effectively moving the black points to the orange points as we have selected the cubic regression. There's not a lot of difference between the cubic, the orange, and linear fit, the blue. The differences happen at the low and high end, with the low end driving our regression. We recommend updating the regression model quarterly, or at least reviewing it quarterly. Lastly, we cover flow-based normalization. Wastewater treatment plants here in Houston vary in size, and flow takes into account populations served by the wastewater treatment plant. For us, we take the flow in million gallons per day, convert that to liters per day, then multiply by the virus copies per liter to ultimately get virus copies per day. Flow at wastewater treatment plants here in Houston has been easily provided by our utility partners. When flow measurements are difficult to come by or missing, the median flow or typical flow can be used. Or a proportion of based on population can be used. For example, the population of a lift station as a proportion of the wastewater treatment plant it flows to can be a way to estimate that lift station's flow by taking the same proportion of the wastewater treatment plant's flow. Thank you for watching this video on missing values in non-detects, calibrating across labs, and flow-based normalization. Please go to our GitHub site to find our code associated with these topics. Support for this program was provided through a grant by the CDC. The Houston Wastewater Epidemiology team would like to thank you for viewing this training video.